We will now proceed to the graphs of the tangent and the cotangent functions. We need to follow these steps in order for us to sketch the respective graph. Please take note the following nature of the tangent function. For y equals a tan b times x minus c, we need first to identify the values of our a, b, and the c. And for the period of the tangent, the formula is pi over b. And for one cycle of the tangent, that is from the negative pi over 2b until the positive pi over 2b. And since that is one cycle, we also need to divide this cycle into 4 equal parts. And lastly, the vertical asymptotes. This is the formula of our vertical asymptotes. X equals the positive and the negative pi over 2b. The border of our cycle in a tangent function are the vertical asymptotes of its function. In this given, sketch the graph of y equals 1/2 tan 2x. Since there is no condition as to how many cycles do we need to show in the graph, therefore by assumption, we need only to show one cycle of this graph. Before we can proceed to the graphing of this function, first, we need to identify the values of our a, b, and c. And from that equation, the value of our a is 1/2. The value of our b is the numerical coefficient of x, which is positive 2. And the value of our c is 0. After that, we can compute the period of this graph, the cycle, as well as the vertical asymptotes. For the period pi over b, the value of our b is 2. Substitute, therefore, the period is pi over 2. And for the cycle, just substitute also the value of our b. That becomes negative pi over 2 times 2 until the positive pi over 2 times 2. Therefore, for the one cycle of this graph, that is from negative pi over 4 until pi over 4. And for the vertical asymptote, that is the positive negative pi over 2b. And the vertical asymptote in our cycle, in this one cycle, is positive negative pi over 4. After that one, we will divide our cycle, which is from negative pi over 4 until pi over 4, into 4 equal parts. Our x, we have the negative pi over 4 and the positive pi over 4. We will get first the midpoint of these 2 points. Since negative pi over 4 in degree is negative 45 degrees, and the pi over 4 in degrees is positive 45 degrees, in between these 2 points is the origin, and that is 0. After that one, we will get the midpoint from the negative pi over 4 until the 0, as well as the midpoint of the 0 until the positive pi over 4. How to get the midpoint? Just add the 2 points and divide it by 2. So the first one from negative pi over 4 plus 0 and divide it by 2, the answer is negative pi over 8. And for the positive side, that is positive pi over 8. After this, we will evaluate each point for our x to our original equation y equals 1/2 tan 2x. For our first point, x equals negative pi over 4, just substitute 1/2 tan 2x. So 2 times the negative pi over 4 as your x. Simplify 2 times negative pi over 4. You can cancel the common 2 and the 4. So you have negative pi over 2. Remember that the tangent is y over x. Therefore, tangent is undefined if the x-coordinate of the point is 0. And the negative pi over 2, that is negative 90 degrees, the coordinate is 0, negative 1. Therefore, x equals pi over 4 in tangent is undefined. For the second value of x, negative pi over 8, substitute to the equation. So we have 1/2 tan negative pi over 4. Get the coordinate of negative pi over 4. In quadrant 4, negative pi over 4 has the coordinates square root of 2 over 2 and negative square root of 2 over 2. So, what is tangent? Tangent is y over x. By applying the ratio y over x, so the y coordinate is negative square root of 2 over 2. divided by the x coordinate square root of 2 over 2. So that is negative 1. Substitute that to the equation, that becomes 1 half. The tangent of negative pi over 4 is negative 1. So we have 1 half times negative 1. And that is equal to negative 1 half. So for x equals pi over 8, y is negative 1 half. If x equals 0, so we have 1 half tan 2 times 0. And 2 times 0 is 0. That becomes 1 half tan 0. And in the unit circle, the 0 degree has the coordinate 1, 0. So applying the ratio of the tangent y over x, that is 0 over 1, and that is equal to 0. And the equation now is 1 half times 0, so the result is 0. So for x equals 0, y is also 0. For x equals pi over 8, substitute 1 half tan 2 times pi over 8. Simplify, we have 1 half tan pi over 4. And in the unit circle, the coordinate is square root of 2 over 2 and square root of 2 over 2. So applying the ratio y over x, and both are positive, therefore the tangent of pi over 4 is positive 1. That becomes 1 half times 1. The value of our y is positive 1 half when x is pi over 8. And for the last point, pi over 4, the same situation with our negative pi over 4. The value of the tangent on that point is undefined. After completing the table, we can now graph this tangent function. So we have now the Cartesian plane of this function. This time we are going to plot its coordinate. First, for the negative pi over 4 and the pi over 4, since they are undefined, we will make use of the dotted line as our asymptotes. After that, we will plot all the points, the negative pi over 8, the 0, and the pi over 8. We have now the 3 points on the Cartesian plane. Next, we will connect this point using a smooth curve. This is the one cycle of the graph of y equals 1 half tan 2x. We will now proceed to the graph of the cotangent function. Take note of the following information about the cotangent function. To get the period of our cotangent function, the formula is pi over b. And the cycle of the cotangent is from 0 to pi over b. And for the asymptotes, we have x equals 0 and x equals pi over b. This time, we are going to identify the values of the a, b, and c of our equation. For the given equation y equals 2 cotangent x over 3, that is the same as by writing into 2 cotangent 1/3 x. So from that, we can identify that the a is positive 2, the value of our b is 1/3, and c is 0. To solve for the period pi over b, substitute the value of b, which is 1/3. That becomes pi divided by 1/3. Now we will get the reciprocal of the denominator and multiply to the numerator. That becomes pi times 3 over 1. Therefore, the period is 3 pi. For the cycle, that is equal to 0 until pi over b. The cycle of this equation is 0 to 3 pi. And for the asymptotes, the given x equals 0, and the second asymptote is x equals pi over b, and pi over b is equal to 3 pi. The next step that we are going to follow is that we need to divide the one cycle into 4 equal parts. To divide the interval 0 to 3 pi into 4 equal parts, we will be using the midpoint of the points. So from 0 to 3 pi, and since 3 pi is equal to 540 degrees, midpoint from 0 to 540 is 270 degrees. And 270 degrees in radian is 3 pi over 2. The next point is the midpoint of 0 and 270, and that is 135 degrees. Converting 135 degrees into radian measure, the conversion is 3 pi over 4 rad. And lastly, the midpoint of the 270 and 540 degrees, that is 405 degrees. And 405 degrees in radian measure is 9 pi over 4. Since x equals 0 and x equals 3 pi are asymptotes, therefore, these points are undefined in cotangent function. So we will only solve for the 3 pi over 4, 3 pi over 2, and 9 pi over 4. For x equals 3 pi over 4, substitute, that becomes y equals 2 cot 3 pi over 4 all over 3. Simplify first this complex fraction. So we have that 3 pi over 4, the reciprocal of the denominator 1/3. You can cancel the common 3. So the simplified form is pi over 4. That becomes 2 cot pi over 4. So the coordinate of the pi over 4 is square root of 2 over 2 and square root of 2 over 2. The ratio for the cotangent function is x over y. Dividing square root of 2 over 2 by square root of 2 over 2, the result is 1. Therefore, the cotangent of pi over 4 is positive 1. And 2 times 1 is 2. For x equals 3 pi over 4, y is positive 2. For the second value of x, which is 3 pi over 2, substitute. So we have y equals 2 cot 3 pi over 2 divided by 3. Simplifying this fraction, 3 pi over 2 times the reciprocal 1/3. So that is pi over 2. That becomes 2 cot pi over 2. We will get now the coordinates of our pi over 2. Coordinate of pi over 2 is 0, 1. And the ratio for the cotangent is x over y. So that is 0 divided by 1, so 0. Therefore, cotangent pi over 2 is 0. And you have that 2 times 0 is 0. So for x equals 3 pi over 2, y is 0. For our third value of x, 9 pi over 4, by substituting, that is the result. And 9 pi over 4 divided by 3 is equal to 3 pi over 4. The new equation now is y equals 2 cot of 3 pi over 4. We will now get the coordinate of our 3 pi over 4. 3 pi over 4 is in quadrant 2, and the coordinate is negative square root of 2 over 2 and square root of 2 over 2. Using the ratio of the cotangent, that is x over y, the answer for that is negative 1. Since cotangent 3 pi over 4 is negative 1, so the value of our y here is 2 times negative 1 is negative 2. We are done with the table. Now we are ready to sketch the graph of this function. On the right is the Cartesian plane of this function. So the two asymptotes are x equals 0 and x equals 3 pi. We have the 3 points in between the two asymptotes. This time, we are going to connect these 3 points using a smooth curve. This is the graph of this function, y equals 2 cot x over 3 on the interval 0 until 3 pi.